Dear students, welcome to this video about RxJS. We are going to talk about what RxJS is and for what it might be used, and then we'll have a look at each of the parts that make up RxJS. So the first question, of course, is what is RxJS and why is there always this connotation with streams and water and whatnot? So RxJS is a library for dealing with asynchronous and event-based code. So it's actually an alternative to using callbacks and promises in your programs. And it revolves around this observable model. So everything in RxJS or in any ReactiveX implementation focuses on an observable. And an observable is just a stream of events that you can subscribe to and then do various things with it. An observable can, for example, be filtered, combined. It can more or less be treated like you would treat an array, but with the difference that it's asynchronous and not synchronous. So to make this a bit more clear, let's start with a very simple example. So the first example is just how you would do an event listener in plain JavaScript and how you would do an event listener in RxJS. So in plain JavaScript, it's just document add event listener, and then you pass it the function. In RxJS, it looks a bit different because first of all, of course, you have to install the RxJS dependency, and then you include various operators and things from it. And the thing that we use in this example is the from event creation operator. So what this does is it creates an observable from an event, from any event. So when you just write from event document click, you will get an observable that you can of course also store in a variable, but here I will immediately subscribe to it. Now anytime I click with the mouse, this click will be logged. So in here, in this example, it might not yet be very clear why RxJS helps you with asynchronous code, but we'll get to that. So I think this should be very clear, so let's head to another example. First this line creates an observable, and an observable is a stream of events, which we've already talked about, and it emits or sends notification to its observers. So what we have here with the subscribe call is an observer, or also called a subscriber. There are a bit of a technical difference, but it's not so important for us. So in our case, I will always talk about observables and observers. Okay, so the second example, where we can see already one benefit of RxJS. Now I can do a simple click counter in JavaScript like this. I will have to create a variable where I save the click counts, and then I can increment them and output them. Now with RxJS, I can use an operator to count the clicks, and there are various operators which we'll get to, but one that's very helpful is the scan operator, and it works similar to array reduce in plain JavaScript. So what we can do with operators is create new observables out of existing observables. So the from event document click creates an observable, and the observable gives me two functions, a pipe and a subscribe function. And in the pipe function, I can put various operators. I can put my scan operator in the pipe function, or I can also put multiple operators in this pipe function. So my observable is piped through an operator and another operator, and out comes another observable, which can again be subscribed to. And what we do here is just a basic accumulator. So we start with the number 0, and each time the function is called, we get the accumulated count and change it. So we have our clicker. Now, what this gives us is an observable that gives us the click count, but as you can also see, there is now no more global variable, or it doesn't have to be global, but it's outside of the function call, so there is an unintended side effect. And with the observables, we don't have this because the state is more or less locked into this observable execution. So, but there are more things that we could do. For example, in JavaScript, I might want to create a function that is throttled so that it doesn't execute each time I do something, but it can only execute, for example, once a second. So this is what this rate here is, 1000 milliseconds. So I want to create an event listener that only listens at click events at most once per second. To do this, I have to do a bit of checks and calculations. So I have to check when the last click has arrived and if 1000 milliseconds have passed since then. And then I will just add the current X position to the count. And this is also output. Please note that here we need to have 3 variables to make this work. With RxJS, I have the same setup as I did in the last examples, but now I have 2 more operators, the map operator and the throttle time operator. And as you can see, they are now all used in this pipe. The scan operator is the same as in the last example, so it takes a value and then we can change the value, and in the next iteration we can change the value again. The map operator is the same as the array map, so you have your item or your element and you change it to another element. But what we also have here is the throttle time operator, which only lets an event pass through this observable once per second. So this is very readable as opposed to this one. And it also doesn't need any variables anymore. So you've seen 3 operators now, but there are a lot more that make RxJS really powerful. And in plain.js we had to use an impure function, which we don't have to do here anymore. Now, here's another example with an interval counter. So what I want to do here is I want to count from 0 to 10, and I want to output a number every 500 milliseconds. You can do this with plain JavaScript, and of course, to be a good citizen, you have to clean up after yourself afterwards and use the clear interval function. Now with RxJS, I can use the interval creation operator that gives me an observable that just outputs something, I don't know, I think 0 or whatever, each 500 milliseconds. And this is just another observable that I can do whatever I want with it. I can pipe it into a take operator. A take operator just tells me, hey, take X values of this observable and then complete. So it takes 10 numbers and it then completes. And here again we have a counter, and we can subscribe to this. Now, to see all of this in action, I've created an example at Code Sandbox. It's just a very simple Vue.js application. If you open it, it will open in the main.js, so please just head over to the app view. And there are all of these examples, just merged together, because it was easier to write. Now, let's start with the simplest example, which was the first that I've talked about, the click example. So we create an observable from click events, and then we just increment our counter. So as you can see, each time I click on the page, the counter is incremented. And the counter in this example is linked to a Vue.js property, these clicks, so I can output the clicks. That's pretty easy. Now I can also do throttling, and I can do filtering. Filtering works the same as with arrays, of course. So on my mouse move, I will use a throttle time, and what this gives me is the observable only runs at 60 FPS, so it waits for request animation frame internally to give me a smooth animation and to not run too often. Then I map the event, the mouse move event, to the client Y, and I only want observable events where the Y is larger than 250, and I just subscribe to this. So this is the line that you can see here. The line stops over here because now we're at the y value that is lower than 250, and if we go down, yeah, it moves with me. Now, of course, this has a position absolute and is moved with the top value. Now, and what else have we already talked about? We've already talked about the counter. So here we have the counter where I just push values to an array, and afterwards I clear the array. This is this counter over here. And the same counter I can also create in RxJS. We just create an interval observable, take 10, and then we count up to 10. Now what you can see here is again a subscribe function with an observer, but this time I have used 3 arguments. So the first argument is what you've already seen, where we receive the next value in our callback and can do something with it. But an observer can also have two other callbacks, an error callback and a completed callback. But we get to that. Now, observables. Let's talk a bit more about observables. Observables, as we've already heard, are streams of events that you can subscribe to. An observable basically has 4 different ways of operation, or it can do 4 things. An observable can be created. You can use new observable to create your own observable, where you yourself create your values, or you can use any of the available creation operators, like the from event that we've already seen and the interval. Now, an observable can be subscribed to, and an observable can execute. And when it executes, it delivers next, error, and complete notifications to the observer. And last but not least, an observable can also be disposed, or its execution can be halted, which was called disposed, but now it's simply called unsubscribing. Now, observable creation. Here's an example where you really create an observable yourself. So an observable also always has just one argument where you receive the observer, and the observer has at least a next, callback, and a complete. So in here 3 values are immediately pushed down to the observer, and the 4th value is pushed after a set timeout, and then the observable completes. But usually you won't do this, but you'll use a creation function like from event, interval, and off, and all sorts of things. We'll get to that list of creation functions. Now, an observer can be subscribed to, as we've already learned. And an observer can have up to 3 callbacks: a next, an error, and a complete. So a next is mandatory. You have to have a next callback, or nothing happens. And the error and complete can only happen once in an observable execution, and only one of them can happen. So if there's an error, it won't ever be completed, and if it's completed, of course, there won't be any more errors. Now, this is what the output looks like of the example on the previous page. What's also interesting is that observable execution is lazy. So if you create your observable like this, nothing will happen. As soon as you subscribe to it, it will run, but only as soon as you subscribe to it. If you don't subscribe to an observable, nothing happens. Now, I've already talked about this, next, error, and complete. And there are different styles that you can write your observers, because the subscribe function has overloads, which means you can pass nothing. You can pass a single callback, which will then be the next callback. You can pass up to 3 arguments for the next, the error, and the complete callback, or you can use an object. It depends on your preferences and the code style that you want to use. Now, the fun part of RxJS: operators. What makes RxJS the loadish for events are its operators. There are many operators for different things. I've already talked about creation operators. We've also used filtering and transformation yet. But there are also operators for joining, for error handling, and other things. And yeah, those are the things that make RxJS really fun to work with. Now there's a complete list at the RxJS page, and it's categorized. So you have all of your creation operators, so there are more than the ones that we've already used. There's also the off, which is very often used. Yeah, the range just gives you a range of numbers, for example. Then there are combination operators, where you can combine observables together and create a new observable. There are transformation operators, like the simple ones, map and scan. There are also other ones. Filtering operators, like debounce, take. What else have we already used? Throttle time, filter. Yeah. Then there are join operators, which join multiple observables together at creation time, and so on and so on. So this is the full list. Now, to understand how an operator works, of course, you should have a look at the official documentation. There's also a companion site to the official documentation, which is called Learn RxJS, and it has loads of examples. And there are marble diagrams, which are very cool and really help you to understand how observables and different operators work. So if we have a look at the scan documentation, it looks like this. So it tells you what it does. Scan applies an accumulator over its observable and returns each intermediate result. Now there is also usually an example how this might work. So of course you have to import it, and you can pipe it to your observable and then subscribe to it. And what this also gives me is an marble diagram. So marble diagrams are called marble diagrams because you have these circles that represent the stream of events. So this is an observable that emits 1, 3, and 5, and it is then piped into the accumulator. And out comes another observable that emits 1, 4, and 9. There is even an interactive page called RX Marbles, where you can move around those marbles to see different results of that operation, which is cool. Now let's have a look at a few combination operators, because they make working with asynchronous code also very, very easy. When you've used promises in your async code, you might have had to wait for multiple promises to fulfill, which you can do with promise all and a few other functions. And this is also something that's very easy with observables. There are even more ways than just the promise all. There are, you can have total control over how you want your different streams to, let's say, fulfill or be merged together. Now let's have a look at fork join, concat, and the combine latest operator. So I have a fork join example here. So again, fork join is an operator that you have to import from RxJS. As everything else. There are some operators that you have to directly import from the RxJS package itself, and there are some that you have to import from the operators package. You can see in the documentation which is which. Now, when I use fork join, I can join together multiple observables. So off creates an observable of specific values. In this case, of this single string, but it can also be an array or something that can be emitted. And there's also a delay function. So this observable creates a string of onCompleted, and this pipe creates another observable that emits after 1.5 seconds. And I do this 3 times at different points in time. And fork join joins these together so that I have a new observable that I can subscribe to. And when I run this, which is this button here, wait for 3 observables to complete, it will give me a value as soon as all 3 of those observables have completed. Now this is similar to promise all. But there's, for example, also the concat, which behaves differently, as it immediately gives you the result of an observable as soon as it completes, not only after all of them have completed, which is why I use a next function in my observer and also a complete function. So what this does is it gives you the result of each observable as soon as it completes, and then it itself completes when all of the observables have completed. I look at again, 1, 2, 3, and 1, 2, 3 completed. Now those are 2 ways that you can combine observables together, but there's another one, and then another one after that, which is the combine latest. So where is this example? Okay, I have it here now. What I have here is 3 buttons, and each of them has its own observable that counts the button clicks. And what combine latest does is, or maybe let's look at the documentation to have a marble diagram. Let's look over here. What combine latest does is it combines different observables together, and it gives you a combined value of all of the observables. But it does this as soon as each stream has emitted a value, which is why you don't see a 1 here, but a 1a as soon as each observable has emitted at least 1 value. And then when each of the observables emits another value, it's joined again together. So you always have the latest combined value of all of your observables. That means that when I click my button, it does count, but I don't see it yet because the other buttons don't have any values yet. They have not omitted anything. So if I click at B, nothing happens again, but as soon as I click C, the C observable will emit a value, and the combine latest can give me a combined value, as you can see here. And now I will always have the latest combined value in my observable. So this is really cool. You have complete control, complete power over how to work with your asynchronous code, which is cool. Now, a few more things that I want to talk about, so you have a good understanding of RxJS, are subscriptions, subjects, and schedulers. Now, subscriptions are easy. We've already talked about subscriptions. Subscription is very simple, as it only gives you an unsubscribe function as soon as you've subscribed to something. And what's also important to mention is that a normal observable is unicast. So this means that you can only have one observer on your observable. So you have your observable, your operators, and one observer. If you want to create another subscription at this observable, you will have a whole new execution context. So this is a one-on-one relationship. And this is also why there are subjects, because sometimes you don't want a one-on-one relationship, but a one-to-many relationship. So a subject is like an observable, but it can multicast to many observers, and each of the observers then gets the same values from this observable stream. As with normal observables, you would have your own set of execution context with each observer. yeah, so that's basically it. But there are also special subjects. So this multicast behavior gives you a whole new set of problems to solve, so to speak, which is why there are 4 types of subjects. There is of course the normal subject, but there is also an async subject where only the last value is sent to the observers, and only when all of the observables have completed. Then there is a behavior subject. It also stores the latest value, but as soon as a new observer subscribes, the new observer immediately receives the latest value. So it also has an initial value as soon as it's subscribed. And then there's the replay subject, which is similar to the behavior subject, but it records multiple values, not only the last value. You can tell it to record, for example, 3 values, or you can tell it to record the values from the last 5 seconds. And as soon as a new subscriber is added to this subject, it will then receive those 5 values or the things that have been emitted in the last second, something like that. Now, another thing, schedulers. I've briefly mentioned the request animation frame scheduler, but there are more. And when you get started with RxJS, you don't have to think a lot about schedulers, because all of the operators that can be scheduled have a default scheduler, but you can override that with your own optional scheduler if you want. And there are 5 types of them. So the simplest is of course no scheduler. So if you don't pass a scheduler, any notification is just delivered as soon as it happens. Yeah, this is very easy. Then there's a queue scheduler, which schedules on a queue in the current event frame. So yeah, this is for simple iterations. And then there's an ASAP scheduler, as soon as possible. This is the same queue that's used for promises. So it runs after the current job has finished, but before the next one. This can also be very helpful. And then there's the async scheduler that works with set interval, which you can use for time-based operations. And animation frame scheduler can be used for smooth animations. Now, I won't get into details, but yeah, maybe it helps to understand what RxJS is doing by default. So by default, it picks a scheduler where you have the least concurrency. So that means that nothing happens in parallel if it doesn't have to. So if you only have a very small set of messages, you can use no scheduler. So you can just emit the value as soon as it happens. If you have a very large number of messages, or if your stream runs infinitely, you can use this the queue scheduler. And when you use timers, the async scheduler will be used. But you might want to replace this with request animation frame, for example, if you want to do animations. Now that's it for now. If you want to dive more into RxJS, I've added some links for you. So rxjs.dev is the official documentation. And there's another page that's called Learn RxJS, which has a lot of examples. Then there's the Rx Marbles, which you've already seen. And then there are 2 blog posts of mine. One is an RxJS breakout clone with RxJS 4, 5, and then there's a game with RxJS 5, where I talk about writing a game loop and about having all of your game state in streams inside of RxJS. This is RxJS 5, but it's not that different from RxJS 6. If you want, if you're very motivated, you can also convert this or migrate this to RxJS 6 if you want, and send me, and I will update these pages. Now, that's all about RxJS. This is not yet important for the projects for your first half. So you can, of course, use RxJS and Vue.js if you want, but it will be more important when you will talk about Angular and Angular development with Ralph in the second half, because Angular has a very strong usage of RxJS since Angular 2, which is why I want to give you a heads up, and so Ralph also has less to talk about and you come prepared to his course. So see you then. Have a nice evening.